In this video, we are going to do the infinitely many solutions case with the 3x3. So we want to solve this equation, this linear system, by letting t be a parameter. So right now, don't focus about what this is. It can say t or n or m or whatever, but I'll show you how do we do that, and especially because you don't want to just write infinitely many solutions. So the first thing that we want to do, remember that when we have problems that look like this, I always want to do 1 and 2, 1 and 3, and 2 and 3. Now, this number in the end tells me what the new equation will be. So it will always be new equation 2, 3, and 3. Okay, so let's first start off with 1 and 2. So I have equation number 1, which is x minus y plus z is equal to 0. Equation number 2 is going to be 2x plus y minus 3z equals 0. Okay, so now let's go ahead and solve this problem. So let's try to remember that we want to eliminate this one, and this one, so that we have 3 variables on top, 2 variables in the middle, and then 1 at the end. Okay, so we want to get rid of this minus this 2x, so we're going to multiply the top by a negative 2. So that's going to give me negative 2x, positive 2y, negative 2z equals 0, and the bottom one is going to stay the same, 2x plus y minus 3z equals 0. This goes away. I'm left with the 3y minus 5z is equal to 0. So remember, this is the first one, so this is going to be my new equation 2. Okay, so what I'm going to have, let me use a different color. So I'm going to have x minus y plus z equals 0. My new equation number 2 is going to be this 3y minus 5z equals 0. And then E3 is going to be 4x. That was a plus 2y minus 6z equals 0. Notice that I'm lining up all of my variables. Okay, the next step is using 1 and 3. So I'm going to use equations 1 and 3 now. So it's going to be x minus y plus z equals 0. That was equation number 1. And now I'm going to use equation number 3. 4x plus 2y minus 6z equals 0. Okay, so let's multiply the top one by a negative 4 so that we can get rid of that 4x on the bottom. So I'm going to have negative 4x minus, it's going to be positive 4y. Minus 4z is going to be equal to 0, and the bottom one's going to stay the same. 4x plus 2y minus 6z equals 0. And remember, this is going to be our new equation number 3. Okay, so this goes away. I'm left with the 6y, I'm left with the minus 10z, and I'm left with the 0. So this is going to be new equation number 3. All right, so let's write it out. So new equation number 3 is going to be the 6y minus 10z equals 0. And then my 1 and 2, 1 stays the same, x minus y plus z equals 0. And 2 is going to be 3y minus 5z equals 0. So now the last thing that I want to do is use 2 and 3 to create a new 3. I'm going to use these two. Okay, so right now what I can see is that I can multiply the top one by a minus 2. That's going to give me negative 6y plus 10z equals 0. And then 6y minus 10z equals 0. Okay, so nothing, the second one didn't change. Now, if you notice, as I've said, this is going to be infinitely many. Okay, because you got 0 equals 0. So we got an identity, infinitely many. Okay, so when we got infinitely many solutions, okay, usually we would be done. But now the question wants it so that t be a parameter. So what the hell does that even mean? Okay, so because the second one kind of canceled out, so our new equation is 0 equals 0, what we're going to do is the following thing. We're going to have equation number 1 be the same, x minus y plus z equals 0. Equation number 2, still same thing, 3y minus 5z equals 0. Now, equation number 3, since we got infinitely many solutions, now we're going to set t be a parameter. So t can be any number that I want. So I'm going to let z equal t. Okay, That's basically what I got. So t is just a number, any number that I want, that I can plug in, because I know that it's infinitely many solutions, so t is just a number that I can plug in whatever I want. So I'm going to let z equal t. So I'm going to plug it in here, and I'm going to solve for y just as I usually would. So I now get 3y minus 5 times t equals 0. Now solve for y. Add 5t to both sides. So 3y equals 5t. Divide by 3 to both sides. Y is equal to 5/3 t. Okay? So now I got what z was. Z was equal to t. Y is equal to 5/3 t. Okay? So now that I know what z is and I know what y is, we're going to plug it into the last one. So we're going to have x minus y plus z equals 0. Let's solve for x. So first, let me move the z over. So I get x minus y equals negative z. Now let me move the y over. So I'm going to get x equals y minus z. Now let me plug in what x and y were. What y and z was. Now y was equal to 5/3 t minus, and z was just equal to t. Now what is this and this? Well, 5/3 minus 1, okay, so I'm going to take 5/3 because it's just going to be t, but what is 5/3 minus 1? So you can put it in your calculator if you don't know how to do this. This is going to give me 2/3 t. Okay, that's what x is. So when I solve for x, y, and z, my x in this case was just this 2/3 t. What was my y? My y was this 5/3 t. And what was my z? My z was just t. That's what it means to parameterize. Okay, so it is a little bit out there. I'm still debating whether I will test you on this or not, because it is a little bit of a high level concept, but that's just all it is. There is a question like this on the homework, and I believe the parameter is n, but you would follow the same procedure. So that's basically it when you have infinitely many solutions. With no solution, if you got something that's a contradiction, it would just be no solution. You won't have to do anything else. Okay? But I did want to show you this so that you get exposed to it. In the next video, you will encounter matrices.